This video is going to guide you through filling out the top flap of section number 2 in your flipbook titled Unit 2 Polynomials. Again, this is the top flap of section number 2, and the title of this section is Distributive Property, Prove It Works. Distributive Property, Prove It Works. And the reason I'm doing this section is because sometimes I feel like I teach students distributive property, we practice it, we memorize all the different ways to do it, and students just do it just because that's what they're told. And I want to show you that the reason we do it is because it works, and we can prove that it works by just looking through a couple simple problems and watching how every time we go through these problems the distributive property works the same as Pemdas. So let's go ahead and look at a couple examples. You'll see where I'm going with this. The first question, question number 1 in your book says, let's check the expression 3 times in parentheses 4 plus 2. First, let's solve using Pemdas. All right, so solve using Pemdas. We've got our original expression, 3 times 4 plus 2. Remember, in Pemdas, we do parentheses first. We have two numbers in the parentheses that are like terms, so we can combine those. 3 times, well, 4 plus 2 is 6. And now we've got our parentheses done, and now we're going to multiply first, and 3 times 6 is 18. There's no addition or subtraction. In fact, we're done at this point. We have an answer of 18. All right, now let's use the distributive property now and see if we get the same result. Let's write our expression the exact same way. We start off with 3 times 4 plus 2. And let's distribute. Remember, distributive property. We're going to distribute the 3 to the 4. And then we're going to distribute the 3 to the 2. So first step is 3 times 4. So 3 times 4 is 12. And 3 times positive 2 is positive 6. And 12 plus 6 is 18. So take a look. Either way, normal Pemdas method or our distributive property, and we get the exact same answer. And I can guarantee you can write this expression any way you want to. Bunch of parentheses with a whole bunch of adding and subtracting, lots of different coefficients in front of the parentheses. Whether you use Pemdas or you use distributive property, you're going to get the exact same answer. So are the answers the same? Yes. Is this enough proof? Well, maybe not. Let's do a few more and see. But you're seeing where I'm going with this. I want you to see that the distributive property, we can show that it actually comes up with the same result as if we were to just use our normal Pemdas way of solving expressions. Take a look at question number 2. Question number 2. I'm going to move this up a little bit. Okay. Let's check 3 times x plus 2. So now we have a variable. Now with a variable, the problem with a variable is you can't use Pemdas. You can use distribution or distributive property, but you can't use Pemdas. We're going to have to give the variable a value. So we're going to say, in this case, let's just try it for x equals 7. So with Pemdas, we're going to go ahead and write down 3 times 7, there's our value of x. We're going to substitute that in there. 3 times 7 plus 2. Remember, Pemdas says do the values in parentheses first if you can combine like terms. 7 plus 2 is 9. And 3 times 9 is 27. So our answer using Pemdas and a value of 7 for x gives us 27. Let's go ahead and distribute now. In this case, let's leave the x as a variable until the very end. So we're going to start with 3 times x plus 2. Remember our distributive property or distribution. We're going to distribute the 3 times the x and the 3 times the positive 2. So 3 times x is 3x. And 3 times positive 2 is positive 6. And you can see these are not like terms. We can't combine them anymore. So now we're done with our simplification using distribution. Now let's go in and plug in our value of x, which was 7 in the beginning. So we're going to use 7 again. Let's see if we can get the same answer. So 3x plus 6 will now become 3 times 7. Oops, I didn't write a 3. Hear that beeping in the background. My phone is going crazy with messages, so sorry about that. This is 3 times 7 plus 6. Let's go ahead and solve this. 3 times 7 is 21. There's my multiplication. Remember, we're going to multiply first and then add. So 3 times 7 plus 2. So 21 plus 2. Sorry, not 2. I've got those two numbers wrong. Let's correct that. Sorry about that. Let's get rid of that plus 2. We have plus 6 over here. Now we'll get it right. This is 21 plus 6. Those are like terms. 21 plus 6 is 27. And you can see again, using distribution, this equation 3x plus 6 gave us the same answer as we got when we substituted the x and used Pemdas. So I want to show you again how the distributive property we can prove through just going through a bunch of examples that it always gives you the same answer as you would have gotten if you would have plugged in the variable first and then solved it with the x value being substituted with a number. All right, let's take a look at, let's answer this question. Are the answers the same? Yes, they are. And again, I don't care how complicated you get, it will always be the same answer. All right, what about something a little more complicated? What if we're multiplying two binomials? All right, well, let's check this expression. X minus 2 times x plus 1 for the value of x equals 7. So first, let's try using Pemdas. Remember how I started with green and changed to red? Oh well, let's do green here. So this is going to be x minus 2. Oops, let's substitute our x value here. We know x is 7. 7 minus 2 times 7 plus 1. Remember Pemdas, solve the variables first. Solve the parentheses first. 7 minus 2 is 5. And next set of parentheses, 7 plus 1 is 8. And 5 times 8 is 40. So using Pemdas, we got a value of 40. Now I'll change to red, which I should have done in the last equation, or last question. Let's go ahead and use distribution. All right, we've got x minus 2 times x plus 1. We're not going to substitute until the very end. Distribution property says we're going to distribute the x to the second term, which is a binomial, and then we're going to distribute the negative 2 to the second term, which is a binomial. And let's go ahead and do that. So this is going to be x times x plus 1. We got a minus 2, so minus 2 times x plus 1. Remember from our previous videos, we distribute these two terms to this entire binomial here. We've got x times x plus 1 minus 2 times x plus 1. Now let's go ahead and go through our normal distribution. It's going to be x times x and x times 1. So that's x times x is 2x. I'm sorry, not 2x. There's a bad mistake. X times x is x squared. X plus x is 2x. X times x is x squared. X times positive 1 is positive 1x, or just positive x. We'll distribute the negative 2 to the x and the negative 2 to the positive 1. And we've got negative 2x. And negative 2 times positive 1 is negative 2. We're almost done. We can go ahead and combine like terms. The middle terms here, positive x and negative 2x, those have the same variable with the same exponent. So those can be combined together. we end up with x squared. Positive x minus 2x is negative 1x, or negative x minus 2. So there is our new trinomial. We've got a squared term, a non-squared term value, and a constant of negative 2. So let's go ahead now and check and see if we get the same answer as we did with Pemdas. Let's go ahead and substitute the value of x into this equation. I'm going to write this in a different color now. So we're going to go ahead and put 7. I'm going to always insert values in parentheses. So this is 7 squared minus 7 minus 2. 7 squared is 49 minus 7 minus 2. Remember, we add and subtract from left to right. So we do the first two terms first here. 49 minus 7. 49 minus 7 is 42. We haven't done the minus 2 yet. Sorry, let me correct that. I wrote the wrong number. It's 42. Now we still have to subtract the 2. Now we have 2 terms left. We're going to subtract the 2 from the 42 and we get 40. There was our final answer. Take a look at the previous answer. Pemdas gave us 40. Distributive property gave us 40. Are these answers the same? And again, we can answer absolutely yes. So I'm hoping this helps you see that we're showing you that distribution actually doesn't change the expression at all. It just rearranges it or simplifies it. And we prove that by seeing that we get the same answer as if we were to just go ahead and use the rules of Pemdas. So fill in this last paragraph. So we can see that distribution can be used to simplify expressions. Distribution can be used to simplify expressions.